Hi everyone, welcome to our video on using the substitution method to solve a system of linear equations. So in the substitution method, what we're going to do is choose one of these equations, whichever one you think is easiest to work with, and solve for a specific variable, and then we'll plug it into the other. So for instance, on this one, let's go ahead so that one's kind of in the way. Let me just kind of scribble it out. So we have, I'm going to call this equation 1 and equation 2. Notice that equation 1, we can instantly solve for y if all we do is just divide everything by 2. So let's divide all of these by 2. And then that way our equation 1 would become y equals 4 minus 2x. Now I wrote it in words, so be careful. Just really make sure though that you're doing it to every part. Okay, and then the second one, I didn't do anything to, so I'm just going to leave it as is. Okay, so we have 5x plus 2y equals 13 ready to go. All right, well, continuing on with this method, now this variable y is completely by itself. So what we're going to do is change that y in the second equation with the y expression in the first equation. So we're going to now do the substitution. So we have 5x plus 2, and then we're saying y is this, is 4 minus 2x. And then that way, and then let's get equals 13. And then that way we have one equation with only one variable. And so now we could solve it if we just distribute. Okay, so now we're just going to solve. So we've got 5x distributing the 2 gives us plus 8 minus 4x and then equal to 13. And then from here, we can combine the x terms. It looks like we would have x plus 8 equals 13. And then we can subtract the 8, and we would get, let's go ahead and show the minus 8 to both sides. Subtracting the 8 gives us x is 5. And then I'm just clouding it. I like to use, so I say cloud. So I like to cloud things that are important, even though if they are not the final answer, at least it's something that I will use eventually. Okay, so we did a substitution and we solved it and we got it. Well, instantly we do another substitution. Now sub again. Now sub our x equals 5 into our first equation there. We had y equals 4 minus 2x. And then if we sub that into our x right here, well, then that means I could solve for y and get a regular old number. So it's y equals 4 minus 2 times 5. And so we've got y equals, well, 4 minus 10, and then y equals negative 6. Okay, so it looks like our solution, and again, they usually want it as an ordered pair, so 5 and negative 6. Because that's our x coordinate and that's our y coordinate, and that's it. Now it says to check your answers. You should probably check it anyway if we're doing it by hand because it's pretty fast. All we have to do, so I'm going to go back to number 1 and just plug in the values into the letters. So we've got 2 times negative 6 equals 8 minus 4 times 5. Now the main thing with this, just make sure they are going in the right spot. So y was the negative 6, x was 5, so it is looking good. And then from here, let's just quickly check. So 2 times negative 6 is negative 12. 8 minus 20. 8 minus 20 is negative 12. Yep. Okay, so it works. And then we could really verify by plugging it in the second one. I'm just going to put a check mark and say, yeah, it would work. You could do it on your own if you want to really verify. But it is good. Okay, so I'm going to skip that work to save a little time. Okay, so that's up to you. So, but we did check it. All right, so for number 2, if I'm going to, and notice they used the brace on this one. So here they didn't. Sometimes they put a brace, sometimes they don't. It just depends on whatever style the person is that wrote it. Okay, so it doesn't matter. They are equivalent. All right, so with this problem though, if I'm going to use the substitution method, notice it looks like it's very easy to solve for a. Now on the second equation, so let's go ahead and label it 1 and 2 again, and let me just kind of cross that out. Okay, so we've got our 2 equations, you can solve for whichever letter you want to solve for in either equation. So if you want to solve for the b in the first equation, you can. It's fine. But do whatever you think is easiest. So in equation number 2, it looks like it is easiest to just go ahead and add 2b to both sides. And I'm just showing the work kind of underneath, so it's not the best form, but I think it's fine for us. So number 1 didn't change, so I'm just rewriting it. And then number 2, I solved for a, and we got 2 plus 2b. Okay, so instead of x and y, they got a and b this time. Again, it doesn't really matter the letters. It's just the same old steps either way. All right, but now that I have equation 2 solved for in terms of one letter, now let's do the substitution. So let's sub the a value, a equals 2 plus 2b, into equation 1. And so that gives us 3. Let's go ahead and mark it. So I'm going to change that a right there into the 2 plus 2b. So we've got 2 plus 2b, and then minus the 8b equals 14. And then now it's one variable with one equation, and we'll go through our steps to solve. On this problem, the next step would be to distribute. So we'd have 6 plus 6b minus 8b equals 14. And careful with b and 6. I try to make my 6 extra curvy and b like kind of straight down. Okay, so don't actually say, oh, that looks like 66. It does, but be careful. Okay, so what we've got, though, we do have like terms at this point. I'm going to go ahead and underline this green. So those are the like terms. And so we've got 6 minus 2b equals 14. And then we can get the b expression by itself if we subtract by 6. And so we've got negative 2b equals 8. And then dividing by negative 2, let me scroll down a little bit, will give us b equals negative 4. And then I'm going to cloud that. That's something important for us. All right, now that we have it, now I'm going to sub b equals negative 4 into, you could technically do whichever equation you really want to, but number 2 here is easier to work with. So let's sub it into that equation 2. So notice on this one, we subbed it into equation 1 because it was the easier one to work with. But you could sub it into any equation that you want. It will give you the same answer. Okay, so let's plug it in though. So we've got a equal, let's write it down again. So there's our equation number 2. And then we've got a equals 2 plus 2, and we're changing b into negative 4. So we would have a equals 2 minus 8, and a equals negative 6. And there we go. And then based on so these are our clouded solutions, so it's probably negative 6, negative 4 is the way to write it. So I'm assuming they would want it in alphabetical order. So there's our A, there's our B. And then to check it, we could do both. Let me just say number 1. So our number 1 is 3a minus 8b equals 14. So I want to plug those values in to verify that this is true. So we'd have 3 times negative 6 minus 8 times negative 4. Does that equal 14? Well, 3 times negative 6 is negative 18. Minus 8 times a negative 4 would be plus, and that's 32. And then yes, that does, negative 18 plus 32 is 14. So that is correct. Okay, and if we really, really want to verify, we could plug it into the second equation. It will work. You could double check if you really want to, but I'm going to skip that again to save a little time. Okay, so that's using the substitution method. So far we have the substitution, and so far you have the echelon or addition or elimination. So you could do whichever one you prefer. It doesn't matter. Okay, so whichever one you like the most, go for. All right, but if you do have questions, please let me know, and thanks for watching.